I just,
Were you born and raised in Hawaii?
well, question, was I born and raised in Hawaii? No, I was born on another island in another ocean. Can you guess? No, you'll have no idea. London. My dad was at Oxford University. So I was born in London.
Yes. Born in London, lived in Malaysia for a while, then in Massachusetts.
Okay, so you're being recorded, by the way. In fact, let me just get the camera, see everybody. Hi, everybody.
Are you doing facial recognition?
That's a good question. I am not doing facial recognition, although this computer does do facial recognition. Windows Hello does that, and it's built into Microsoft Windows. And so it is being used in certain areas at Microsoft. But in any case, let's go back to the slide. What happened here? Okay, so it's recording. Okay, so my dad, so he asked, oh, Malwarebytes. I've heard Malwarebytes are good, and I'm at Microsoft. I never use any third-party thing. I use Microsoft Windows Defender as my malware, and I don't worry about anything, and I've not been hacked or anything. But you know, my dad and I don't want to say yes, do you use Malwarebytes or not, or don't use Malwarebytes. But he started hearing about it, and I said, oh, maybe I should try it. So he sent an email to them and said, hey, maybe I should upgrade to the paid version. And somehow, I wasn't there. Somehow somebody called him from Malwarebytes, or he said they were from Malwarebytes. He said, hey, I can help you fix your computer. And so my dad said, oh, you sure? I don't know, I shouldn't have trusted you. And gradually that person called and then said, hey, review this my little thing, and then it'll fix this one problem. And then the next day he called, it did fix it. And my dad said, yeah, it did. Then he said, oh, well, you have a problem? So every day he kept on calling back and saying, hey, I can help you more. It's like my dad saying, wow, I'm getting free advice for fixing my computer. It's like, wow, it looks like it's working. So my dad was starting to trust this guy. So eventually, you know what two-factor authentication is, right? Where you have to give their phone number as well as your password and stuff like that. My dad was getting, this guy from supposedly from Malwarebytes said, hey, I need to get your 2FA for this one thing. I have to charge you $5 for this one thing. It's only $5. I mean, so essentially he got the 2FA and the road access to my dad, and he hacked every account that my dad had, everything. All bank accounts, all savings accounts, all social security, everything. So that's a warning. This hits home, right? He was compromised. Now, how do you fix that? Well, you have to go and take your dad and drive him around to the bank and change it, all that, change all your security numbers and all that and whatever, right? And change his email and all that. True story.
Yeah.
Just in August. So that was just a couple months ago. Yes.
How did he realize that he was hacked?
Because he talked to his sons.
Oh, okay.
Well, you've been hacked, but also we saw lots of huge withdrawals from some of his accounts. And I said, oh, that's not good. So it's something that we really want to protect everybody from. It's not something that you don't want to have to deal with this. Okay. So at Microsoft is one of the biggest targets of hackers around the world. We don't advertise that. We want our customers to trust. But because Microsoft has the keys to a lot of data and stuff, we don't want to be compromised. And what's the number one way of being compromised? Hacking or whatever. You've heard of it. It's probably called phishing, right? You've heard of phishing attacks. Here's an email. Click on this link. And if you think, oh, it's from my friend, I'll click on the link. You've been hacked. That kind of thing, right? Phones, watches. You get a phone call. Anyone get a robocall, by the way? Those are very annoying. It's very easy to create a program that calls every number. For I equals 1 to a million, call this number. If it doesn't exist, go to the next one, right? It's very, very easy to do that. And if I get one hit out of 1,000, it pays off, right? So getting security hacks is very easy. Okay, so Microsoft is very, very, very adamant about security. We have all this training and stuff like that. This is actually, we have security training, access control. If someone gets hacked, blah, blah, blah. So Microsoft has a huge cybersecurity team and stuff like that. And we actually actively investigate hackers from around the world, in particular in North Korea and in Iran, because those places, it's very hard to create a weapon and send it to missiles and all that. Well, it's very easy to just send a phishing. Go on LinkedIn and go find somebody who works on Microsoft. Hey, send you something. Here's a link. Click on this link, and then you compromise. You got all this data, right? So it's very easy to do that. Okay, here's actual screen a shot from one of my trainings for phishing attacks. So here is phishing big time. Practically lives on social media. She's always posting vacation information and location details, connecting with some friends and people. Is this a do or a don't? Should I publish where I am all the time? I mean, it's very easy to do that on social media, right? I can say, here I am, I'm doing this, doing that, right? I'm on vacation next week, I'm gonna go to Spain. Well, that means your home can be hacked by burglars or whatever, right? So got to be really careful about these shows, the do or don't kind of thing. Okay, we talked a little bit about this. What is the internet? Okay, there's this guy. Anyone know his name? Anybody name? Starts with Tim? Yeah, who said that? Microsoft hardware for you? Very good. Tim Berners-Lee, back in early 90s or late 80s, actually, figured out how to send data back and forth between two computers. Actually, it was done quite a bit earlier than that. Actually, at BBN, where I used to work, was the first demonstration of something called time sharing. Now, time sharing, I don't know if you've heard of that before. You heard it with condos, right? The condominium or apartment. Time sharing means in August, I get it, in June, you get it, right? But in time sharing in computer science was, back in the day, in the 80s, was when you could use the computer for like half a second, then I could use the computer for half a second, and then someone else, and the computer could arbitrate and figure out who can take time and do that kind of, use computer access, use computer resources. Okay, so initially, Tim Berners-Lee and HTML was born. Who knows what HTML is? Yell it out, yell it out.
Hypertext markup language.
Yeah, whatever that is. It means text, right? So it was very easy to just get text from one computer to another, no matter where they were in the world, which was interesting. Right? That's an interesting capability, even on your phone or your watch or whatever. Initially, it was just text, and they said, okay, why don't we add something else, like bigger text, smaller text, different sizes, color. Or then there's just, I constantly adding a link, have a link, so you click on one thing, it'll go to another computer or another website, and you get more data. Then it's add pictures, add videos. In this day and age, there was no way I could figure out how to get a picture on the screen. I mean, this is 4K of memory we're talking about here. And how big is a picture? Like 1 megabyte? That's way, way, way more than 4 million. 1 megabyte is a million. This is 4K, 4,000. That's a huge difference. So there's no way you can get a picture. Okay, there are two kinds of computers, requesters and responders, right? So when you're on a phone, you like go to a website, you're requesting something, and then your response could be something like a text file or a movie or video, picture, that kind of thing, right? They both have, they're very, very smart. Both ends are very smart. They have computing power. So why don't we add this capability called scripting or running code at both ends? And that's, I'm going to demonstrate that today. You can actually write scripts on both ends. But that means you're actually running code at the back end and the front end. And that code can be malicious. So you have to be very careful about whose code you allow to run. Okay. One end is in the hands of a criminal, and you don't know. Okay. Who knows what an IP address is? You know. It's a group of numbers from 0 to 26. Okay? It's like 1, 2, 3, 1, 2, 1, 2, 1, 2. Okay? How many possible IP addresses are there? Oh, okay. Excellent! Microsoft hardware for you. It's 4 billion. Oh, sorry.
Please don't stop.
I don't want to kill anybody. It's scared. Okay, 4 groups of numbers. That's 4 billion. 2 to the 32nd is 4 billion. This is 2 to the 8th. To the 4th. So that's 4 billion IP addresses. How many people are there in this world? 7 billion. Who said that? All right. Oh, sorry. Okay, there's 7 billion people in the world. So isn't there a problem? What if everyone, how many IP addresses do you have? I have like 1, 2, 3, I mean, right? So there's a problem. And this was recognized about 15, 20 years ago. And so so then we renamed this into the IPv4. And then we came up with a thing called IPv6, which has 128 bits rather than it's 32 bits or whatever. So we're much less likely to run out very soon. Okay. Okay. I'm going to hack a web page locally. I'm going to show you how that works. So I'm going to go to some website and I'm going to change the content. I'll let you read about my Captain Crunch decoder ring. Okay, I'm going to go to this website. I'm going to, oh, you can't see. I need to change my,
Take this time to remind everybody to please silence your phone.
I'm going to duplicate my screen so that whatever I see on the screen is going to be the same rather than extend. I forgot to do that. So, oops. Okay, can anyone see that? Okay, so here is a web browser, and I just went to one of my blog things, entries. This is, what is a C0005 crash or whatever, right? And this is something on my blog that I wrote in June of 2004. Who wasn't alive then? Oh, you were born? Oh, I'm not that old.
You can't be in college.
Okay. Well, my son was 1 year old at the time, right? Okay, so I'm going to go hack this site. What I'm going to do is hit the F12 button. What does that do? It actually shows the actual, when I made the request to go to that website, that blogs, that what's called the URL, that's a request. It goes and returns a string, this data. This is essentially what happens, gets sent back to me, okay? So you can see there's all this stuff in here. It says, notice there's a script here, a JavaScript and a query and loads of function and all these other things. This is my blog. It's I wrote this thing, and yet it has all the scripts in here. I didn't have that stuff. So essentially this blog is being hosted by Microsoft MSDN. So that's why that has all this stuff in here to make the blogs more constant in styling and stuff like that. But what I'm going to do is I'm going to click on this button here, which says select element. I'll click it, and then I'm going to click on what I want to select. I'm going to go right here and click on that. So now what that did was it brought me to the part of the script that is that text. What I'm going to do now is I'm going to hack that. I'm going to double click down here. Okay, so I double click and I can say modify. Okay, now I'm going to hit the F12 button again. So now look at this web page. I just hacked it. Okay, not secure. I can do put whatever I want in here. I can say, hey, look, Joe, someone's hacked my thing or something. You know, you can say something wrong here, right? You actually hack this. This is a local hack, okay? So no, I think the red around here means it's recording that screen, and I think it's okay. Okay, I think it's recording this screen now. Okay, well, let's just see what happens. Okay, so let's start by creating our own web browser, okay? So I'm going to go to my start menu. I'm going to type and see there's a button called Visual Studio. Has anyone installed Visual Studio? You have, a lot of you. It's free. You can just download it from visualstudio.com and just download it, okay? It's very easy to do. I'm going to say File, New Project. And I want to create something called a web browser, so I'll just type web in here. Actually, no, I want to create a web client. So I'm just going to use a WPF app desktop. So I'm going to create a C# WPF app, Windows Presentation Foundation Desktop. You can do this in multiple languages. You can use BASIC or Visual Studio or C# or C++. I think this gentleman over here did C++, but maybe not Visual Studio. But I'm going to do this one. Click it, and I say next. And I'll give it a name called My Browser. Now you'll see when I create a web server instead of a web client, you'll see that the steps are very similar. Okay, so it's creating what's called a WPF desktop application, which means it's just a application that has a form on it, and here's the form, it's his main window. That's all. So let's add something to this guy, okay? So am I going too slow or too fast, or is this just right, or?
Any questions? Everybody understands?
Okay, so I'm just gonna add in here something called a text box. So I'm gonna choose it and open the toolbox, and I grab this thing called a text box, and I'll put it over here. So, and I wanna make it a little bigger, longer. So that's where I can type in a URL, okay? What is a URL? It's a Uniform Resource Locator, or URI, Universal Resource something. Okay, so I look at the properties of this text box, and I give this text box a name. So this is going to be TB for text box. And then I can add a button. I click on it here and choose a button, and I go over here, and there's this button here. It says button, and that's the content. It says button. I'm going to change that content to say go. So this is the button where I'm going to say, when you click on this button, it'll actually navigate to the web page. So that's my button. And then what I want to do is add this thing called the web browser control. It's in here somewhere, so I'll just type web here, web browser. I'll click this guy and drag it over here, okay? And what I want to do is change its size. So its size, I want it to be automatic, width and height. And I also want to give it a name. I give it a name, for lack of a better name, WB. Okay, so I have these three controls on here. Web browser, text box, and a button. I'm going to double click the go button. And I'm brought to this thing called an event handler. This will handle the button click. So when this click happens, what do I want it to do? I want to say this.wb, the web browser control, I want to navigate to a site, and what I want to do is pass in a string here. The string is whatever I have in that text box, right? So I'll just put this.tb.text. Okay, that's all. That's my one line of code here. So what that means is when I click the button, it'll tell the web browser control to navigate to the website, web URL, whatever that URL was. Okay, I would like to go back to the text box, which is this guy. And I'm going to give it a default text. Instead of saying text box, I want it to say http:// what was that address? I sent it to you. Well, I think it's in the slide. Here it is. No. Yeah, here it is. Yeah, well, we can argue about that later. I'm just going to go. The reason I chose this is I wanted to show you the relationship between a domain name and an IP address. And so this is on a particular IP address, 1382.28.61. Remember I asked you to do that on your network?
Oh.
Yeah. Okay. So now I'm going to say run this program by hitting F5. Hitting F5, what it does, it takes this whole program, compiles it, runs it, and stuff like that. Okay. So here is my form. I hit the go button. What happens? It goes and clicks, and it goes and navigates to that thing, and gets me this web page. Now it happens to be that that IP address is msn.com. And the way I figured that out was I did a ping search to find out, ping msn.com/a essentially, and it tells me what the website address is. But because of that, I could actually go to msn.com, and because this is actually working here, so I can go and find out what I can click on, Rays versus Astros or whatever. So I just wrote a web browser, very easy to do and very simple. You can do it. It's free. It's got no security in it, so it's got these security warnings that are available. So, but very, very little security is built in, right? But I can go to, I can say no. Oh, wow. Turn my volume down.
Want to get baseball?
Baseball, is that baseball? I don't know.
Basketball?
Okay, but in any case, it's very easy to create a web browser and web browser control. You can make it multiple tabs and things like that, okay, but you have to be aware, there's no security on it. Okay, so I think I want to say view, slideshow, don't use presenter view. Then it'll go onto this. Okay, now they're on the same screen and it's being recorded. Okay. Okay, so create your own browser, okay? Minimal security. Now I'll do the same thing for a website, okay? So in order to do that, I'll say close the solution or file, close solution. So this is gone now. And I'm going to say create a new project, file, new project. And this time I want to do a web project. Has anyone created a website? Oh, so I'm going too slowly for you guys, right? You've done it. Well, here we'll go into the nitty gritty because it's pretty simple to do. And I'm going to choose this guy, C# web ASP.NET web application. And I'll give it a name, W web app 2 or something. Okay, so now it's going to ask me what kind of web app. There's a zillion web kinds of, and it gives details here: web forms, MVC, model view controller, web API, single page application. There's different kinds. I'm just going to do the default web application here, web forms here. So it's going to create this thing called a web app 2. Now, what is a website? It is a endpoint that is a responder for URLs, right? So you can go to wendyshaw.com or msn.com and you're essentially asking that computer, here, give me some information. And so at msn.com, they're in the news business, so they give you news. If you go into google.com, it's a search. If you go to, different things, amazon.com, what do they do? I forget, something, shopping or something.
Max.
Okay, so while that's creating that, it's just about done. Okay, so it creates this website and it shows me these different things here. And I can go and look at these things called the Solution Explorer. Let's minimize this window here. And I can see it's created all these things for me. So I can, in particular, go to this thing called a default ASPX, which is the website which is the web page for the default. So when you go to this website, this is what will be shown. It's called a master page, or it's loading this master page thing. Here it is. It's just a page that looks like this, getting started, blah, blah, blah. So if I want, I can change code here. So what I'm going to do is change the code, and I'm going to change it to, I'm going to say split. So I can see at the bottom is what it looks like, and at the top is the script that gets, or the text that gets sent. So when the response is sent, there's this thing called the response. It's sent, that is the response, and it'll be rendered like this. The browser says, okay, a div tag and H1. H1 means header, means large font or whatever. And that's what all those different things, hypertext is what that means. There's an H2 in there for a header size 2 getting started, things like that. But what I can do in here in particular is I can, a free web browser framework, that's for using and JavaScript. I'm going to hit enter here and change it. I'm actually going to put in some code here. I'm going to say /% equals date time dot now dot toString. I just want to know the date and time on this website. Okay, and I'll even say dot toString quote hour, minute, second, millisecond, and then I'll say close quote, and then I'll say plus hi Cyberhawks. Okay, so now if I bring up my error list, I'll see there are no errors. So it looks like it's good. So I'll just hit the F5 button. F5 button. Notice when I did the web browser, I hit the F5 button. It ran the program. Here, when I hit the F5 button, it runs the program. Well, how do you run a website? It actually starts an instance of a browser. And that browser is starting up here. And notice it goes to this website called localhost. Localhost means it's right on this machine. It's just not visible anywhere in the world. It's just right on this machine. And it's loading up this thing called default ASPX page, which is the page I just modified. Okay, here's my page. And see, it says, hi Cyberhawks, and it says the date and stuff like that. That's cool. Now, what if I hit the refresh button here? What's going to happen? Change the time and nothing else. Useless website, right? So we can make it do a little more. So now what I'm going to do is go back here, stop debugging. This time I'm going to say, let's add a button. See these things here? This is a standard toolbar. Let's add a button. Where's button? And let's put a button right over here. So I created a button here. Let's add a text box. There's a text box, okay? So now if I double click the button, very, very similar to what I did with the button on the client. Here I am on the server, the button click, I can say this dot text box 1, and notice it gave a default name, text box 1 dot text equals quote, you clicked the button. And I want a date timestamp too, just because then I can see what it is. Too many. Okay, so I'm actually writing code here. Semicolon. Now this time you just get Control F5 to run it without run debugger. It's a little faster. And here it is. And so creating a website and creating a web server, website and a web browser is very different logically, but Visual Studio makes it look very similar, right? You're adding a button, adding a control, stuff like that. So if I click that button, what's going to happen? It's going to say, you click the button, and then I didn't make it big enough to show the date time, but you get the idea, right? So essentially what I can do is when you click this button, you can say, okay, you want to buy whatever's in your shopping cart? You can add whatever you have to this thing called a shopping cart. Essentially, you've made a website, right? You can create all these things, and there's power in that. Okay. Okay. What if we wanted to make this thing visible to the world? Let's do that. Okay, this thing called Web App 2, right? First thing you need to do, I've already done this step. One thing you do is you can get a domain name. There's a lot of vendors that get a domain name. They're very easy to find. They advertise a lot, and I'm not going to tell you which one to use, but I did years and years ago. I reserved my name, and when you get a name, all it does is reserve the name www.yourname.com or .xxx or whatever you want to do. Y, ZZZ, doesn't really matter. But it gives you the rights to use that name and no one else can. So anyone know what a cyber squatter is? Cyber squatter, one person.
Oh, they just sit on domains and.
Yeah, cyber squatter. So if you're a cyber squatter, you would reserve the name Microsoft with 2 T's or without the F. And then people who try to misspell Microsoft.com, they'll go to your website. So it's a way to get traffic to your website, sort of what deception, right? So, or maliciously, yes. And what you can do is then you can say, okay, I'll sell this site to Microsoft for $1 billion now that and you can make a lot of money that way. People do. That's cyber squatting. But anyway, you can get your own domain name. You can have many ways to host your website. You don't have to do it with your machine. If you host a website from your own machine, what does that mean? You have to have your machine available to be the responder to a URL 24 hours a day, 7 days a week, unless it's going to, people aren't going to get to it, right? So there are a lot of people who will give you free computing technology, well, not necessarily, but computers, resources to host a website with your domain name, 24 hours a day, 7 days a week. Not only that, like Microsoft Azure offers this for, I think for a year for free or something. I don't know.
It's free depending on how much traffic.
Yeah, okay. That's a big point. If you have, you're going to have a sale on Monday. I'm going to sell all my stuff on Monday. So you're going to have a huge amount of traffic, internet web traffic on Monday. You want to have lots and lots of computing power for it, not just a little laptop here, right? Otherwise, you'll have all the customers complaining they can't get to your website. So what do? You use one of these This thing's called in the cloud. Have you heard of the cloud? This thing called the cloud. These machines, the computing resources that are available to you very inexpensively, but they dynamically can scale. So if you have 1 billion website hits one day and 0 the next day, you get charged only for the day where you get the most, and it'll scale automatically for you. So it makes it very easy to create the next best thing, and not worry about computing power. You don't have to buy more computers and manage them. You can just use a cloud service like Azure. Okay. To host your website on your machine, every version of Windows has this. Windows 10 is this. You go to your Programs and Features control panel, and you go to Windows Features, turn Windows Features on or off. And then you can see, I already have it checked, but you just choose this guy and it'll default turn on all these other guys. Internet Information Service. That's what a web browser is in Windows. Okay, you can do it right now on your own machines. Turn this on. And what that does is it creates a folder on your machine called inetpub www, which I'll show you. Okay, so there, and my local drive C, there's this thing called inetpub, Internet Publication, publish. This thing called www, worldwide root. Okay, I did that. So if I go here and create this folder is the www root. So if I create a there's already this thing called my docx. I'm going to say here and go to that. The reason I can't do it is because of a security feature that I'm going to show you, and I can't do it from Windows Explorer, but I can do it from here. I'm going to say notepad test.txt. This is a test document. And if I misspell it and no one yells at me, I'm good. Okay, test document. Okay, I just created this test.txt document in this folder. You can see it right here. I couldn't do it directly from here because this is in a folder that's been secured. So that's another thing that I was going to tell you. It's in a later slide. But in any case, I have this thing called test.txt. Now, if I go to a web browser, any web browser, and I go to localhost, and I say test.txt, there it is. So what I did was, with anything I put into that folder, is made public to everyone who can access that web service, that web. This is now being published on this machine as a website. So it's a website that serves up this thing, a document. If I make this website publicly visible, then this document can be seen by everybody in the world. Okay. Now, imagine that. That's huge power to somebody who's just trying to start a business. Okay, so I'm trying to start my business, and here it is. It's my web app 2. What I'm going to do is take this thing and publish it. I'm going to say build and publish. This is go publish web app 2. And where am I going to publish it? Now here I'm going to just publish it to that folder, and that folder is here. Well, actually, let's create a folder. Let's call it Cyberhawks or something. New folder. Okay, so now I copy this string, this path, and I paste it into here, this folder. Choose a folder. I'm going to browse to this folder. Okay, see, Cyberhawks, right? I'm going to say publish. And now you can see all these various steps are doing and it succeeded. So it actually did. So if I go over here, I think I'm going to get an error. I haven't finished everything yet. But you can see in the Cyberhawks, it was an empty folder. Put all this stuff in here. Okay. There's one more step I need to do. Well, I'll just show what happens when I don't do this step. If I go here and I say now go to localhost Cyberhawks. I'm going to get this error because I didn't make it an application. I need to make it an application. So in order to do that, you have to go one more step, Internet Information Service, which is IIS controller. All I need to do is navigate to that particular website, folder, and make it an application. There's this thing called Cyberhawks right here. I just say right click and convert to application. And I'll say yes, okay. Now this is where there's a whole bunch of features to secure your website and all that, authentication and authorization and stuff like that. You can read about that later online and stuff. It's beyond the scope of my talk here, but this is very good to be aware of it. Now if I hit the refresh here, it's waiting and waiting and waiting. It has to, the first time it has to stuff. And eventually, there's my page. It's right now, it's public on the entire network that this can see. So because I'm on the Seattle U secure Wi-Fi, if anyone has a computer here, you can actually see this guy. I see someone's going to try. I've never tested this. I may be lying. It could be. I may not have set firewalls correctly or anything like that. This is the first time I'm using this particular network. You need my IP address. That's a good point. So what's my IP address? Actually, no, you need the computer name. The computer name happens to be, try this. Calvin HSB. Ping that. Calvin HSB/Cyberhawks. It may work, it may not work. I've never tested it. And whether it does or not, it's not that important. But what is important is that theoretically, this should work. If it doesn't, it could be because of firewalls and Seattle security and stuff like that.
If it doesn't work, you're fired.
Okay, you can fire me. You don't have to pay me. So let me try it. So the site would be I don't know how Seattle University network is working, set up and stuff.
Yeah, you said HSB.
Oh, I did the wrong thing.
Did it work for you, Ed?
Okay, well, there it is. It's working for me.
You did it wrong. Use HTTP.
Yeah, you might have to use HTTP at the first, but it seems to work for me. Another, if it doesn't work, you can try this. I'm going to say ipconfig to get my IP address. If I spell that right. Okay, you can go to this website here, 10.176.41.39.
Careful, giving it to a room of hackers.
Ah, yeah. Yeah, worked for me. This time I went to the IP address.
You know what, you might be on, I was just thinking because there's SU Secure and then SU Secure Guest.
Yeah, I'm on
You might be on,
No, I connected it to
I'm on
SC Secure.
SC
oh,
Secure.
you're on it with your account.
Yeah, with my
Oh,
account.
okay, never mind. I was
So-
wondering if maybe you were on the guest.
But that's a good point. It could have been a different Wi-Fi. Absolutely. You're correct. So whether it does work or doesn't, it can do this, right? So you can each go home now and create your own website on the SU network. I don't know how the SU Wi-Fi is divided. For example, we're in this building called Pigot, and it has this Wi-Fi and it may be a Pigot subdomain. And I don't know anything about this architecture here locally, so maybe that's why I can see it and maybe not. But so those are the details that you may need to work out later. In any case, we've now created a website and we can make it published to the whole world, right? Okay, iterative exploits. We already talked about robocalls, but it's very easy to create a program that is a for loop. You created a for loop, right? For I was 1 to a million, do something, right? Send a phishing text. For each IP address for this, right? You can do something, test and exploit. And if you get a response, then you can get, like, here's try this. This is MSN. Computers can execute these very, very quickly. Oh, by the way, let me show you how I got MSN's address. I said I was going to show you that. Let's do it for Google, right? Ping/a. Oh, here's Google's address. 17227 blah blah blah. And I can look up those addresses on. There are lots of online websites that'll tell you mapping between domain name and the IP address. Okay. Okay. Iterative exploits. Okay. Office. Microsoft Office. Has anyone used Microsoft Office? Yeah, quite a few. Oh, that's good. It's a pretty useful thing. Has anyone used macros in Microsoft Office? Couple. Has anyone used? Okay, well, let's go a little bit further. Office includes, let's do something like start Word. So there's this thing called Microsoft Word. It helps you do this thing called word processing. Now, for you, those of you who are young, word processing is writing documents for your teachers. Okay, so here I'm going to choose a blank document. And I've already done this step to enable this thing called a developer tab here. See this developer tab? I'll show you in this. Here's how you do it. You go to custom word options, customize ribbon, and you click on this thing. And what that does is it now allows you to do what I'm going to show you. Now that's true of Office documents, including PowerPoint, Word, Excel, Outlook. So you can do this same thing, okay? So here, what I'm going to do is go and record a macro. Well, before I do that, I'm going to minimize, change the size of the screen. So here's my Microsoft Word. I'm going to try and move it over to the right here. I'm going to choose macro. I'm going to choose create. And I'll say, do you want to replace the existing macro? Sure, why not? So I'm going to create a new macro. Oh, actually, you can see my old macro here. Pretend you don't see that. I was expecting, let me start over. Let me start with Excel, because I'm more familiar with Excel and how it persists macros. Excel starts with a J. What I'm trying to show you is that you can script something very easily, and that script can be very good or very bad. Okay, so here's Excel. And I'm going to say, I have the developer thing here. So I click on developer and macros. Here, I can give it a macro and I can say create. I can give it a name, called T and create it. So I'm creating this macro called T. What I'm going to do is say set x equals create object word.application. And then x.visible equals 1. And I just say F5 to go. Create object. Did I spell it right? Well, it looks like it's doing something. Essentially, what I'm doing is using Word, Excel to create Word, or vice versa. I can use Word to create Excel. Or I can use a website to script and say create Outlook. Let's do it Visual Studio. Okay, I'm going to go to this thing called the C# interactive window here. View, other windows, C# interactive. You can also do an F#. Has anyone done anything in F#, by the way? Yeah, I think they teach it here, right? Or something.
And languages, And computations, which you have to take if you're a CS major. Class I took it.
Okay, I'll just do it in Visual Studio because I know Visual Studio much better. I can say var rr equals quote high, semicolon. So I just created a C# program, which is very complex. It creates this variable called RRR and it lets it be high. I can say RRR, hit enter, and it says hi. So it tells me the value, right? So let's do this. I can say, I'm going to create something called dynamic OE equals activator. There's this thing called an activator. I want to use the activator if I can spell it right. I was telling Wendy I need to, it's hard to type when I'm standing up. Activator, create object, create instance. And I want to create an instance. And create instance takes a parameter. What parameter? I need to type. So I'm going to create a type of something. So I'm going to say type from program ID Excel application. Now I'm going to demonstrate this using Excel, but keep in mind you can use Outlook, which is very, very malicious, or can be very malicious. Do I have the? Okay, so I just executed this thing called OE object Excel equals create Excel application, right? So now let's make object Excel visible. So OE.visible. So what did it do? If I go, here it is. I have all these word instances. Excel. Here's my Excel. So it created this thing. Let's manipulate it. OE.left equals 0. I moved it to the left. OE.top equals 0. See, I moved it around. I'm manipulating Excel. Excel doesn't have a workbook yet, so I can say OE.workbooks.add. Oh, did I? No, I didn't. I hit enter in the wrong place. Okay, at the end of the line. So I created a workbook. So I can say OE.cells, parentheses, 1 equals quote high. I think it's not parentheses, it's these guys, what do you call them? Square bracket. And you have to hit enter at the end of the line. See? So I'm able to manipulate and change the data in Excel. I can also do the same thing for Word or the same thing for Office. And I can also do a for loop in my program. And the for loop could say, for each contact in Wendy's address book, send an email that says, please click on this link, right? And send this script. Now, what did I just create? I created something that once one person clicks it, it spreads like wildfire to everybody because it goes to everybody's Outlook web contact list and sends itself to everybody on the contact list. And then when everyone gets it, they click on it, it goes ad infinitum, goes to everybody. And that's a very, very, very easy thing to do. I'm not going to show you how to do it. I'm just going to say it's easy. And so, so that's why scripting, Microsoft said, wow, back in the 20 years ago, it's really nice to have these features to Excel and Word so you can program them and manipulate them very easily manipulated maliciously. These are some of the links to the object models. Like remember that I said there's a thing called workbooks in Excel. In Word, there's a thing called an insertion or a caret and a selection, and there's indexes and all these things. So in order to manipulate them, you just need to look at your object models in public. And so here's some links. Or you can just in the macro editor, you can say F1 to help you go like this. And I actually wrote some There's a blogger a couple of years ago, manipulate Visual Studio from Excel or Word. So Visual Studio can be manipulated as well, right? It's called automation or something like that. Okay, here it is using the C# interactive window, create instance of Excel application, make it visible. Okay. Word manipulates Excel. Here's what I was trying to do from Word. Visible true workbooks here, and here's a for loop, right? So you can imagine, just change this to say Outlook, and instead of saying workbooks, contacts, and just for each contact, send email. Very easy to do. As a developer at Microsoft, over the years, I've developed features for multiple products, right? And obviously, I want my features to be used, so my boss will say, "Hey, your feature is really used a lot. You get a raise." But the problem is, what if your feature allows malicious use? You don't necessarily want to have your feature on for all default installations. And so having this, somebody created this macro capability, but it has to be off by default. Remember, we had to turn it on by the developer options and things like that. Also, have you ever received a link to a spreadsheet and it says, caution, macros are enabled and you have to disable them and stuff like that? You want to make sure that you don't, because if it comes from someone malicious, who is possibly malicious or has been hacked, it could be your dad, but he could have been hacked, right? So it could be seem to come from him. It may not, so you have to be really careful about these macros, because once the macro runs, it can compromise you. Okay, so creating a bogus hyperlink is very, very easy, because all you need to do is create some text like, this is a good link, whatever you want behind this, right? So that's so easy. And if I hover over it, where does it go? There. I mean, see, you can actually do that. It's so easy to do. And it's so easy for a hacker to do. And it's so much safer for a robber. He doesn't have to get, put on his mask and go rob a bank and say, hold up. He can just sit in his living room in his underwear and send links around and get much more money, right? Okay. Good so far? We're going to talk about this thing called a buffer overrun. Okay. Here. Example, which has some amazing C++ code. Okay. That's it. That's the entire code. I have mostly comments. But what I have is this thing called main. That's the main entry point for this thing, this program. It gets, whenever you start this program, something calls this thing called main. The process starts, it calls main. And it has a couple local variables, one called local int, one's a buffer of 8 characters, which is a character array of 8. And it starts with 6 characters in it, right? Actually, it's 7, there's a null terminator. So it's got 7 things in there. And then another int 2. Okay, so 1, 2. And then I call this thing called do something with string, which is defined up there. And I pass it 3 parameters. One is a 3, and the buffer itself, but one's a value 4. Okay. The reason I use 1, 2, 3, 4 is because those are easy to see on the stack. So we're going to look at what happens to these things on the stack. Okay, and to do something with a string, what does it do? All it does is string concatenate to the buffer. It adds this to the string. So the result will be foobar, and then add this to it. So it'll be foobar, add this to the string. Okay, that's my very fancy C++ program. I'm going to hit F5. I'm going to take a drink of water. Ask anybody any questions. Is this enjoyable? Is this useful? Is this good? Good pace?
You also recorded it.
Well, I'm hoping the recording will come out okay, but I don't know. We started a little late and stuff, but okay. Has anyone debug C++ code in Visual Studio or anything? It's pretty amazing. This is a very good debugger. And I can see these things called registers up here. At the very top, it says registers. What is a register? Storage. Give the man a Microsoft hardware. Microsoft hardware. I don't know. Storage, a register. How much data can a single register hold? and look right up there, and you can see there's a few registers. There's like 8 or 10 or whatever. How much data can it hold? How wide is that? 8 bits? 8 bytes? How much data can a register hold? 32, where did that number come from? You already have.
Yeah.
Hex, that's right, yes, hex. Yes, on this particular machine, running this particular program is running, it's a 32-bit program. You can actually run both 64 and 32-bit programs on this machine. Currently, you can see those registers are only 8 hex addresses. They're only 8 numbers. I should put it this way. This is 8. This is 8 wide. It's a 0, 0, 0, 0, 0. Okay, and it can only go, and it can have letters too. The letters can go from 0 to F, 0 to 9, and 8F. Right. So there's 16 possible values. Right. And 16 times 8 is not 16 times 8. Each digit can have 4 bits, and there are 8 sets of 4 bits. So there's 4 8s are 32, right? So 4 times 8 is 32. 2 to the 32nd is, we already talked about this with IP addresses. It's 4 billion, right? So this can actually address 4 billion. There are 4 billion possible addresses in a register. Okay, and if I ran this thing as a 64-bit processor, it'll be very, very different. The registers will be twice as wide. It will have twice, and the debugger will still show them the same way, but it'll just be bigger. But in any case, what I wanted to show here is the buffer override. So let's concentrate on that. But before I get to that, notice there's just a little breakpoint here. I'm at this breakpoint. So it has already created this local int and this buffer, and it's about to do this string. But you can see these things in this thing called modules window. In my modules window, scroll around. You can see what modules have been loaded in this process, this test process that I'm debugging. Here's my console application, which is my main program. It also loaded these things. Where are they? So you can see that they come from this place. And you can see some symbols and stuff like that, symbol file, and what version and stuff like that. What are these guys? Libraries. DLL, what is the DLL? Dynamic Link Library, that's what it stands for. But it's just a library, it's just a bunch of functions. Where do they come from? They come from this Windows, wow, what does that mean? They're part of Windows. Every program that you load on your machine loads some of these, depending on what they use. But they get loaded. And not only that, they get loaded at a particular place. So here, I can see that my program is loaded at 00AD, blah, blah, blah. And this one is loaded at 76, this one goes 74, 75, 75. The operating system ones are typically loaded in this region, 7 something, on a 32-bit process, okay, in Windows. Okay. But that's just a hacker wants to know where these are. Why? Because kernel 32 has the functions that I can call to get your credit card number, or your photographs, or your private information, okay? Or I can format your hard disk and erase everything, get any file I want, because these same files have those in memory, those functions. So if I can cause this program to execute some code in here, I've just compromised. Okay, so we'll take this, these registers. There's an EAX register, EBX register, etc. But there's one called an ESP. What is that? Do they teach computer science here? Yes, stack pointer. Well, E means extended, because this is actually extended architecture from a 16-bit machine. See, this is a 32-bit architecture. It's extended from a 16-bit architecture, which is actually extended from an 8-bit architecture, because the original one was called the A register, A, B, C, and D. Then when they went from 8 to 16, they went from 8 to AX, from the name A and B to the name AX and BX. Now, so because AX is the A extended, but now they extended it even further. So why do they name it? They have to say extended AX. So extended A extended. That's what EAX means. And this is over a series of decades or whatever, but the EAX register, but the ESP register is what we're very interested in now. So this is the ESP register. I'm going to drag and drop it over here and see what it looks like. Keep in mind, but the EIP, what does that stand for? Instruction pointer. Yeah, some people are mumbling it. Instruction pointer. It says that it's executing this instruction at ODA13F5. And if I go here and look at the right click and say view disassembly, go to disassembly. There it is, AD13F5. See, this is the code that I write. Do something with string, and this is what they get compiled to. Compiled into these bytes called 6A04, AD, whatever, but it's a push for and a load effective address, things like that. Okay. The instruction pointer says AD13F5 here, and that is exactly what this value is, because that's the next instruction to be executed, because we're at a breakpoint. We froze this machine at this instant. Okay. And we're looking at the stack. The stack pointer is F5 here. No, it's B7C here, which is this guy. So the stack is pointing exactly here. And what's there? It's got my foobar in it, right? You can see my foobar right there. And if I scroll down a little bit to make room to see further what happens to the stack as I step through this program. So right now the stack pointer is pointing here to this foobar. And the next instruction it's going to execute is push 4. So it's going to put a 4 right here if I hit the F10 button. So I've hit the F10 button, which goes in steps. Did it put a 4 here? Right here, yes, it did, right there. So then it's going to load, and it's going to load effective address into ECAX. I'm just going to step over that. And it's going to do another push, F10. And you can see it added here. After there's 4, it added this guy, B7C, which is B7C, which is right here. This is the address of foobar. So put the address of foobar right here, because this is what I want to add the string to. Okay, so then I'm going to call this function. No, it's going to push a 3. F10 is going to push a 3. So here it added a 3. So we've started here, push some things onto the stack, these 3 things, right? These things got added to the stack. This is called the stack frame. Okay. When I hit F11, it'll step into this function, but it'll also push this address here. When I return from the function, it wants to return to this function right here after that. So that's going to be a 1402. So that's going to be pushed onto the stack. So I push F11 here. It put the 1402 onto the stack. Okay. So this is the return address. So when this function returns, this is the return address. But you can see how it just goes and adds more things to the stack. It put this thing, this thing, this thing, this thing. Okay. So now I'm going to hit F10 and go through this function, that string cat. Okay, now I'm not going to go into details on this, but I'm just about to call string cat here. Okay, what it's going to do is add the string to this buffer here. When I do that, it broke here. Here it added the foobar. Here it added the string. Add this to the string. It didn't. It did what I asked it to. But the problem is it destroyed the stack. It actually put 74206 here, because that's a 2 for HIS. It added these things here. Okay, that destroyed the stack, which means that when this function returns, the main function return is going to come through here and give an error message, right? But it's actually going to try and execute the code here. We didn't have the. If I hit go, it says exception thrown. It's trying to execute this stuff. EIP is 73206. It's at 73206. It says access violation, buffer overrun, access violation. You cannot execute instructions here. Okay. The operating system says you have no right to write to this address. Okay. That's what a buffer overrun is. So if you're malicious, you can just take that string, instead of making it add this string, add a virus there. You've compromised the entire machine. Okay. That's how a buffer overrun works. So now I've just trained you to be a hacker. There are lots and lots of workarounds or protections against these buffer overruns, because they're just so everywhere. The GS switch adds a canary to protect against buffer overruns. There are a lot of other compiler operations that will prevent buffer overruns. Okay. We'll talk about mitigations. Operating systems and tooling have worked to try and protect you, okay? Just like the TSA, when you go travel on an airplane, they're trying to scan you and they try and poke you and they try and take all your stuff out of your bag. We're just here to protect you. Let us do our job. They're really just trying to protect you, right? I mean, that's what they're saying. But these operating systems and tooling, they have improved hugely to prevent these kinds of exploits, like the scripting, like turning them off, for example, by default, or like the buffer overrun protections, okay? There's these things called firewall. There's these things called anti-malware. There's antivirus, things like that. Routers and stuff like that, passwords on routers and stuff. Okay. Anyone use a browser on your computer, like a Chrome browser or Internet Explorer or Edge, things like that? You've used those. You create multiple tabs. Now each tab, when you create multiple tabs, each tab is its own process. It used to be that they were all in the same process. But that meant that if one tab crashed, all of them would crash. Because on Windows, and it's on a lot of different operating systems, a process that crashes has no effect on another process, unless that other process was listening to it. But it has essentially, they're all isolated by this thing called process boundary, okay? And that process boundary means you have some protection. If you're going to a malicious website, it won't be able to affect the other tabs on the machine, or even go to other places on your machine, like where your credit cards are and stuff like that. Okay, so you can see here I have like 10 tabs open or 15 or whatever, and you can see each one of them has its own instance of a browser process. Okay. You can also see that okay, we'll talk about threads. What's a thread? Like when you're sitting there and sewing, right? Yeah, it is. But a thread is much more than that. I try to teach people over the years what a thread is. You can imagine if you have a restaurant and you have a kitchen in the restaurant and you have one chef there and he's cooking all his meals and there's 50 people in the restaurant, he has to cook a meal one at a time, right? That's one thread. He can only do one at a time. But if you have two cooks in the kitchen, you can get this thing called parallel processing. So you can double your throughput pretty much, right? But what if you get 50 cooks in the kitchen? There's a point of no return, right? They're going to be idle a lot of the time because you're not going to have enough, or because you only have one refrigerator, you may have one stove, things like that, okay? So inside these things, you can see there's 42 threads in this one processor. There's 41 in this one, there's 35 in this one. You can see how many threads there are in each of these processes. These are the cooks that are actually doing the work. They're actually fetching information, stuff like that. And so they can improve performance, but to a limit, just like in a real kitchen. You can only improve performance so much. Okay. But what's good about it is you can have protection between threads and between processes. Now on this machine, if I go and look at the machine right now, I'm running here. This is a live view of every single process running on my machine right now. You can see that there are lots and lots of processes on this machine. This is called Process Explorer, similar to Task Manager, but a lot better. And it shows me all the different processes running. And you can see that there's several dozen or whatever, so a couple hundred. Here's PowerPoint and Outlook and stuff like that. They're all running. But you can see all the different threads that are running and the number of threads and the amount of memory. But how does a computer do all that? Isn't that amazing? That's running on this one little laptop computer over here. All these hundreds of processes that are actually running. Well, what happens is they get swapped, right? This guy wants to get work, it will get a microsecond at a time, and then this one will get a microsecond at a time. That's what happens. It's happening in the background all the time. But these processes are running in what's called these processes are isolated from each other. If one crashes, it won't crash the other one. Like here's IIS Express. This is Internet Explorer Express. That's when I was doing the debugging of the ASP web page. Okay. So these processes are isolated from each other. And if they're not, when a process wants to access something that's shared, like there's only one screen on this machine, or only one disk, or only one keyboard, it has to go and ask the kernel. Say, hey, kernel, put something on the screen for me. So the thread has to switch to kernel mode. And when it does that, when you're in kernel mode, you have access to everything on the machine. And so if you can crash in kernel mode, you infect the entire machine. So a crash the entire machine will, has anyone ever seen that? Seen these? This is a kernel mode crash. The machine cannot recover. Everything on your machine is dead. Okay? It just cannot, you must reboot. And this happens because something happened in kernel mode to cause a crash. Now, 90% of these, or 95% of them, very, very high percentage of these are due to video drivers. Okay, so if you have any kind of crash that's affecting your entire machine, it's very likely to be a video or a network driver, but usually a video driver. Okay, and it's also called a blue screen of death for obvious reasons, I suppose. Okay, I wrote a program called ManSpect a long time ago, and here I'm just showing you that kernel 32 is loaded in memory at the stagger of 778, and this is Notepad, a very, very simple program. And you can see kernel 32 is loaded, and it's got all these different attributes on the regions of memory it has. Like this is read-only. So if you try to write to this read-only region, it'll crash. So that's a security thing. You'd much rather have the thing crash than read your credit card number or something, right? So I'd rather have a crash than a credit card security violation. And that's what this is, read-only. This says execute read. It can actually execute code in here, in this particular region, things like that. Okay, so these are protection attributes on different regions of memory here in Notepad. Okay. Address space layout randomization. Does anyone remember Windows Vista? Vista. It actually was a very good operating system. It didn't get much good in press, but it was very good for security. One of the reasons is because it introduced this thing called ASLR. And what that does is it makes the address of kernel 32 random when you boot. So if you boot, it'll be a different place every time you boot. What that meant is a virus driver can't say, oh, 7744 is always where I get your credit card number. It's a different one every time. So it made it much harder to get your particular credit card information. There's another feature called data execution prevention, which is pretty technical, I suppose. But you can, remember I was showing you the regions that are no execute, and you can read, write, and no execute. You can actually mark this thing to say, turn on data execution prevention so that you can prevent programs from executing in various areas of memory. This is actually a performance option in Windows. Yeah. Okay. Then there's user-facing security. Okay, that's what I was struggling with earlier when I tried to write something in that folder. Sometimes when you try to write something to a folder, you say, hey, this is my machine. I should be able to write or delete something in this folder. And the computer says, oh, you don't have rights to, access denied. Well, that's because there's user-facing security. And that means that certain folders are protected. So if you're a user, me, I can't go to other user and delete or even see the other user's data unless I have rights to it, re-granted rights. But there's also true that program files and a lot of areas, operating system areas, are protected on the disk. It used to be you could write anything to anywhere on the disk, but now you can't because of these things called user-facing security. Okay. Okay, built-in security options. There's a whole bunch of security options in different languages. So, for example, C++ has all these guys. Anyone heard of Spectre or Meltdown? Yeah, that was big what's this year? Or yeah, about a year ago, right? Just over a year ago. Last summer, I think, just over a year ago. Oh yeah, it says 2018. So Spectre is actually a hardware failure. It is not a software security hole. What happens is there's this thing called speculative, it's get complicated, but speculative execution of a branch prediction. What happens is it allowed one process to see memory of another process. And that's not good. So Spectre mitigation means can only be mitigated by slowing things down. So ever since then, computers have been slower because software has been put in place to protect people against Spectre and Meltdown. Okay. C# and VB also have very many security issues, security warning in code. There's this thing called Roslyn analyzers. You can also write your own analyzers. You might have seen these messages. I don't know if you have or not. Okay, security features via Visual Studio extensions. You can go to the online gallery and see lots and lots of third-party extensions that have to do with security. And I haven't installed any of these, but just know that Microsoft is not the only option for security when you're dealing with anything in Visual Studio or whatever, okay? Third-party products and stuff. And then References, there's a bunch of references and Q&A. How are we on time?
We do have to be out of this room at 2:30. There's something else happening at
Okay.
2:30. So, yes, if you have questions, please ask.
Questions, answers? Sure.
I guess my question, I mean, obviously you've been doing this for a while, but how do you even like, I guess, learn about this? Is it just from like experience of like jobs that you've worked or, because I mean, the stuff you showed us is really, I think a lot of us have maybe taken classes that like, we know what threading is, we know what, registers and all that, but.
Oh, you know all this stuff, right? Okay.
Well, no, not like in the detail and depth that you know it, but we know probably at a higher level and you know it so in detail,
A lot of, how did I learn it? Mostly it's experience, yeah. It's
Yeah.
Mostly just doing it.
This is old because before all of the stuff we learned, he had to do that.
Yeah, but I mean, still even just all the little detail, I don't know.
Is it more on the job stuff or just like hobby?
Tinkering around, yeah.
Well, keep in mind that I went to school to learn about computers for 1980. So everything I've learned,
Like, wow.
like the internet,
So you can develop.
well, not in school. So everything I've shown you here is not from school. Right?
Yeah,
So, yes, it's on the job. So I think that colleges, like Seattle University, can give you a good beginning, like giving you a background on various things. But you, in order to learn some stuff, find something you like in computers, something that you really like to do. Because you're gonna do it more. You're gonna, if you like it. Don't find something you hate. Because if you hate it, you're not gonna do it. And if you're not gonna do it, you're not gonna learn. So if you like web, if you like web design, if you like word processing, if you like
Games.
What?
Do you like games?
games, find something you like. Something, or let's say it's creating videos or social media, or it's just something you like. Because the more likely, you'll be more likely to do it if you enjoy it. So I enjoy computers, so I just, that helps to learn. Yeah, it's learning. And all these things I showed you, most of them were free, right? Everything was free, so.
and we also do have, I'm sure you guys all know, but access to free Microsoft products through school.
Oh, really?
Yeah, we get Office.
Yeah,
Cool.
we get a bunch of,
65, I think.
Thank you. I didn't know that.
I mean, you gotta go like, do you know where you have to go? There's
It's
like,
like Green Spark or something.
Yeah.
you like, if you just search Seattle, use Microsoft Office, I think something will come up.
Yeah, they just sent an email like last week saying, oh, the old thingy,
like how to access
they,
it.
we don't use anymore, we're using Azure Student or something like that.
You can probably just Google it.
Yeah.
They're saying.
But you can get Office for free.
For those who did not get one, I have more pens. I didn't want to.
Hardware.
More Microsoft hardware.
How do we get a job at Microsoft?
I know, right?
I would say that to get a job at Microsoft, you really need to get passionate about what you do in computers. And if you can show passion in what you're. No, I These are Microsoft hardware, but if they don't write.
Is there a 30-day returnable?
Oh, my other question, is the Stack Overrun, that's like a Stack Overflow?
Stack Overflow, Stack
Okay.
Overflow, they're the same thing.
Okay, that's what it seemed like, but I wasn't sure if there was something I was missing.
And it's very rapid in C and C++ because the original C libraries had string functions that did not take how long the string was as a parameter. So they would be, like string cat, it didn't know how long the string is that you're trying to cat, so it has to try to figure out what. And it could be malicious.
So you could like literally write
Because
code.
back in the 70s, there was no malicious code. So. Yeah, you're welcome to come take a look too, yes?
Could you be more specific about how you show this passion? Is it about just messing around at home with your computer and writing all sorts of
Extracurriculars like joining the Cyberhawks.
Yes, yes, excellent, excellent example.
Great on
Doing anything that's
resume.
extracurricular, creating your own website, having, showing interest in a hobby that has to do with computer stuff. But Microsoft isn't the only game in town. It's closer too, so, but there are lots of opportunities. Amazon, I think, has really good opportunities. I don't know any much detail about it. I know that they're doing a lot of spying on the phone. I mean, they have these listening devices. I can hear everyone's private conversation.
And Microsoft.
Microsoft has.
He's recording you right now.
I know.
I'm recording. I told you I'm recording. I just stopped the recording right now.
Did you hear that, Microsoft, I just read an article, I think, that said Microsoft just, found out that I think their rating has been,
Yes, there have been.
I know, because you said something about that earlier. that
Yes.
They've been,
I go to these security things internally, and there's some things I cannot tell you.
yeah,
But I can tell you there's this thing called the periodic table of the elements. You know, Mendeleev and carbon, hydrogen, nitrogen, all that. Every malicious actor is given an element. And I know what Iran is, and I know what, you know,
Yeah.
I mean, yeah, so.
right, so that you
I-
have like full teams obviously dedicated to that kind of